Students, now we are going to solve the problem in the double heat exchanger. This is an NTU method that is entirely different from the previous method what we solved is that is the LMDT method. So in the NTU method, we can approach the problem in the two ways. So in a problem itself, you can given in terms of solved by the means of NTU method. Otherwise, in a problem, the effectiveness value is given. So you can by the two ways you can choose the problem in NTU method. Otherwise, we have a four temperatures T1, that is a T2, that is a T1, and there is a small T2. So in a four temperatures, any two temperature is given. So 2 is given, it is a 2 is unknown. So we have this case means we can choose the NTU method. So clearly that so previously three temperature is given, directly go to the LMDT method. But in this case, any two is given, any two is unknown, we can go to NTU. Otherwise, the NTU value or effectiveness values that is given in the problem, we can choose the NTU method. Now we can move to the problem. So the problem, what does enter in the counter flow? The flow direction of flow is given. The counter flow double pipe heat exchangers enter the 15 degrees Celsius. First we draw the one simple diagram for the flow. So this is the hot fluid flows in the inside inner tube. Then we have a surrounding, there is a concentric pipe. So this is the cold fluid flows in opposite direction and leave there. So cold fluid is water. Then which entry temperature, that is a T1 is equal to 15 degrees Celsius. Flowing at a rate of say that is a 1300 kilogram per it entered to 15 degrees is flowing at a rate of 1300 kilogram. It is heated by a oil. Please note that it is a heated by a oil. So hot fluid is nothing but that is oil. It's having a specific heat say which is equal to that is equal to 2000 joule per kilogram Kelvin at a rate of 550 kilogram per hour. So the mass flow rate of 550 kilogram per hour at inlet temperature of say that is 94 degrees Celsius. This is the given data. So for an area of 1 meter square, you have the overall heat transfer coefficient that is U is given that is equal to 1075 watt per meter square Kelvin. A is equal to 1 meter square. Then finally, what are the things that you're going to find is determine the total heat transfer and outlet temperatures of water and oil. So what is the Q? Then what is the outlet temperature, that is T2 of that is oil, then small t2 which is equal to water. So these three parameters are asked. Okay. You clearly understand from the diagram, it is the counter flow heat exchanger. Hot fluid is oil, cold fluid is water. So in the problem, the specific heat of cold fluid that is not given. Because it's a water, water has a standard specific heat. We consider there is a 4186 or 4180 joule per kilogram Kelvin. So don't forget the value of specific heat of water. Okay. Is if you solve the problem in NTU method, you consider the four following factors, important factors. So first factor is you have to find CH and CC. That is called, that is a heat capacity of hot fluid and heat capacity of cold. This is equal to mass of fluid into specific heat of hot fluid. In a CC, there is a mass of cold fluid into specific heat of cold fluid. So from that CH and CC, which is C minimum, so which is C minimum. So from the value CH and CC, which one is C minimum? So if one is C minimum, other is C maximum. Better write in a clear way. C is equal to C minimum, and then CH is equal to C maximum. If CH is C minimum, then CC is equal to C maximum. One is C minimum, another is a C maximum. Then second parameter is, second term is, you have to find, then from that value you have to find C. C is equal to ratio of C minimum divided by C maximum. This is the second parameter you are going to find. Then third parameter is you are going to find, that is NTU. NTU is equal to UA divided by, that is C minimum. So that is given there. So number of transfer NTU is equal to UA divided by C minimum. So here the C minimum is smaller value of MH and CH, that is also given, that is equal to CH, that is a CC. Then fourth parameter is you are going to find effectiveness. Effectiveness is equal to Q actual divided by, there is a Q maximum. So this is a formula given there. This Q refers to, that is the Q actual. So Q actual is equal to MH into, that is CPH into T1 minus T2 divided by, what is the Q maximum is, that is a C minimum into, that is a T1 minus small t1, inlet temperature of hot fluid minus inlet temperature of cold fluid. Otherwise, which can be written as MC into CPC into T2 minus T1 divided by C minimum into T1 minus small t1. So here note that this is the one condition, this is the one condition. This is the given in this two formula. Okay, if cold fluid is C minimum, so this is the cold fluid is C minimum, you can use the formula here. This is use it for hot fluid is C minimum, you can use this formula. So this is the two formula, it can be directly related with this one. Here the effectiveness is given, effectiveness is equal to, this is the actual, this is by maximum, this is the actual, this is the maximum. Okay, these are the four important parameters in the NTU method. Now we proceed the problem. And before the problem, you may note that you may find the effectiveness with the help of n is equal to number of transfer units, C is equal to C minimum, C maximum with the equation, otherwise with the help of graphical representation. So this is for the parallel flow and this is for the counter flow. So we can choose the counter flow because in a problem is a counter flow, not a parallel flow. Okay, now we can find the first step. First step is to find CH and CC, which from that which one is C minimum. So CH is equal to, there is MH into, there is a CPH into T1 minus, sorry. So CH is equal to MH into CPH. Here mass of hot fluid is given. So mass of hot fluid, which is equal to what, 2000, 550 kilogram per hour into 2000 joule per, specific it is 2000 joule. So 550 kilogram per hour into 2000 joule per kilogram Kelvin. So kilogram gets cancelled. Finally, we are getting the value in terms of joule per hour Kelvin. So hour can be converted into seconds with the help of 3600 seconds. So 550 into 2000 divided by 3600. Finally, we are getting the value which is equal to not 550 or 500. Please wait. Okay, we are getting the value that may be around, that is equal to 305. Better you take 500, not that this is 550, that is you can better you take a 500. So you can take, that is a 500 watt per Kelvin. Similarly, you are going to find the value for, that is CC. CC is equal to MC into CPC So mass of water is given. So mass of water is equal to what? 1300. Specific heat, you know, that is a 4180 joule per kilogram Kelvin. Here also divided by 3600 is used because we are converting hour into second. Finally, you are getting a value of Cc is equal to 1511 watt per Kelvin. So this is a Cc, this is a Ch. So from that Cc and Ch, C minimum is equal to what? That is a Ch, which is equal to 305 watt per meter Kelvin. You may find that is C. C maximum is equal to Cc is equal to 1511 watt per Kelvin. Okay, you find this two value. Then second step is you are going to find what? C. C is equal to C minimum divided by then C maximum. So it is equal to 305 divided by 1511. We are getting C, which is equal to 0.2. This is the second step. Then third step is you are going to find. So this is the first one. This is second one. Then third step is you are going to find, that is NTU. NTU, which is can represent means of n, which is equal to UA divided by, that is a C minimum. So in a problem, use value of U is given. Value of U is equal to 1075 watt per meter Kelvin. So it is equal to 1075 watt per meter square Kelvin. The area is for 1 meter square. For calculating C minimum, this is equal to, that is equal to 305. Finally, you are getting then NTU is equal to NTU value that may be nearer to, that is a 3.52. Third step you are going. Then fourth step is you are going to find that is called effectiveness. So effectiveness you may calculate it from the formula also. So 1 minus expression of, say, that is minus n into 1 minus c divided by 1 minus c into expression of minus n minus 1 minus c. You can use this equation to find the effectiveness. Otherwise, this is a equation for by graph. We have a value that is equal to around 3.52 for the C minimum by C maximum, that is equal to 0.2. We have this line. So around value of 3.5, sorry, around the value of 3.5, we are getting almost the value which is equal to, from that graph we are almost getting value of F10 is equal to 0.94. This is the fourth one you are going to find. So 1, 2, 3, 4 you are going to find. Then from the for 4 1 you are going to find the heat transfer. So already you know, so effectiveness is equal to Q actual divided by, that is a Q maximum. Here you are going to calculate it for the hot fluid. You calculate for both the fluids. First you are going to find for the hot fluid. Okay. So Q actual is equal to effectiveness into, that is a Q maximum. So effectiveness into Q maximum, that can be written as, that is equal to C minimum into capital T1 minus small t1. So effectiveness from the data graph you are going to find 94. C minimum value, that is equal to 305. Capital T1, that is the entry temperature of hot fluid, that is equal to what? 94 degrees Celsius, and entry temperature of cold fluid is 15 degrees Celsius. So 94 minus 15. So from that you are going to find the Q actual, that is equal to around, that is a 22.69 kilowatt. This is the value you are going to find the actual heat transfer. Okay. then sorry, not actual, so into Q max. Okay, that's right. Okay, then from that actual temperature, you may calculate the exit temp. First, you find the problem, the actual temperature, the actual heat transfer that is going, you are going to find the exit temperature and exit temperature of hot fluid and cold fluid. Okay, here for a fluid, hot fluid, so QH is equal to, that is actually heat transfer is equal to mass of hot fluid into specific heat of hot fluid into T1 minus T2. So already QH you know, that is called actually heat transfer. Then mass of hot fluid you know, specific heat of hot fluid you know, entry temperature you know. So T1 minus T2 is equal to QH divided by, that is equal to M of H into CPH. We know that is called T2. So T2 is equal to this T1 minus QH into then M of H is into CPH. So T1 you know, QH you know, mass you know, CPH you know. From that value, what is the exit temperature of hot fluid? Hot fluid exit temperature. So the hot fluid exit temperature that may be around, that is equal to 19.74 degrees Celsius. Similarly, that may be for cold fluid. Cold fluid. Here, one thing is you are going to calculate it. Already you know. Then effectiveness is equal to Q actual divided by Q, that is equal to what? Q maximum. If what is the condition you are using here? Here in the effectiveness, Q actual divided by Q maximum. If hot fluid is C minimum, for our problem, hot fluid is C minimum. Okay, then hot fluid is C minimum, you can use this formula, that is equal to CPH into, if a cold fluid is C minimum, here using this formula. Here this is a hot fluid because hot fluid is C minimum. Is not the condition. So this is important condition here. Hot fluid is C minimum. So this is a formula to find the actual heat transfer. If a cold fluid is C minimum, if use the different formula here, MCP into CPC you are using. So this is a different. Here this is MPC into CP. This one is you are using. Okay. Then from the cold fluid, then QC is equal to MC into, that is a CPC into T2 minus T1. Similarly, QC you know, actually transfer you know, then CPC you know, CPC also you know, T1 also you know. So what is the outlet temperature of, that is a cold fluid? So which may be around, that is a 30 degrees Celsius. So this is the second one we are going to find. This is the third one we are going to find. So in the NTU method, you must follow these 4 steps for solving the problem. First one is, again I repeatedly, first one we have to find the heat capacity, which one is C minimum. Then you are going to find the C. Then third step is you find the NTU. From that NTU you may calculate the, after the effectiveness may be from the graphical method or analytical method. From that NTU, which is equal to actual divided by maximum heat transfer. If these two conditions are satisfied, if C is, this is the C minimum, so you may calculate it for the hot fluid, then C minimum divided by. If it is a cold fluid, you can use this one. So there is a way to find the actual heat transfer. So numerator may be differ in a case of hot fluid and cold fluid, which is having a C minimum. So by this condition you are using, this is the Q hot divided by, that is a Q max. This is a condition of time. For Q hot, you may written as there is mH into CPH into delta T divided by C minimum into T1 minus T1. So this is a specific area you have to choose them carefully. for finding the actual heat transfer. Okay, thank you.